The purpose of this first video for lesson 17 is to review what we have done, specifically in the last few lessons, and to tie it in with what we will be doing in this lesson. So what we did in the previous lessons is we studied the relationship between a population mean and the values that some random variable could take on. So we have looked at probability distributions. We've looked at probability distributions for discrete random variables, where our table would look like x and p of x. And maybe our discrete random variable was the number of threes that you get after you roll a dice 4 times. Well, you could get 0 threes, you could get 1 3, you can get 2 threes, you could get 3 threes, or you could get 4 threes. And then we would fill out all of these probabilities. We would fill out all of those probabilities, which I'm not going to do, but this is like the type of things that we did back in lesson 12. And then we talked about probability distributions for continuous random variables. And we talked about how the probability distribution for a continuous random variable is, it could be a normal curve. We've looked at normal curves, and we know that we have the mean in the middle. And then we would move standard deviations to the right and move standard deviations to the left. For example, like what we did with Kevin Hart and Shaquille O'Neal, we were able to find the probability that a man would be shorter than Shaquille O'Neal. And what we would do is we would find what was Shaquille O'Neal's z-score. And then once we knew that z-score, we would find the area to the left of that. So we have already looked at the relationship between a population mean and the values that the random variable could take on, like say the height of Shaquille O'Neal, if our random variable was the height of men. What we're going to be looking at in this lesson is the relationship between the population mean and the means of random samples of the population. So what does that mean? That's a lot of words. So to help wrap our heads around that, let's look at this picture here. The title reads, the population with mean mu and standard deviation sigma. For example, let's say that we are looking at the heights of men, and this is just an example. And I'm using this example because we have looked at probability distributions for the heights of men. Back last week, I'm clicking through Moodle now. Back last week, we used the fact that the average height of a man in America within like a certain age range. 1 second, I'm going to my Moodle thing. So I just found it. We saw that the mean for the height of men was 69, and then the standard deviation for the height of men was 3 inches. So again, this is just an example to give us something to wrap our heads around. We already know how to answer problems like this. Well, what is the probability that a man is shorter than Shaquille O'Neal? What we're going to do this week in this lesson is, what if I just don't take one man? What if I take 40 men? What if I take 40 men and I choose that to be one of my random sample out of this total population of all men? So in this rectangle, imagine this entire rectangle holds the heights of all men. So the total rectangle is the population. Let's say that I just take one sample. Let's say I only take men that live in Rockingham County, or I only take men that live in Guilford County, or I only take men that have children. Any sample, it doesn't matter. What could I say about the average, the sample mean of that sample? How could I compare the sample mean of that sample? Not just one man, not just the probability that one man is taller than Shaquille O'Neal or shorter than Shaquille O'Neal, but what's the probability that the average of a sample of, say, 40 men is going to be shorter than Shaquille O'Neal or taller, either or? So what we're looking at here, probability that the average of 40 men is less than the height of Shaquille O'Neal is like about 85 inches. So let's say this. So again, to put things in perspective, what we already know how to do from previous lessons is to find the probability that one man would be shorter than Shaquille O'Neal. And his height was about 85 inches. The inches isn't really necessary, but the probability that one man would be shorter than Shaquille O'Neal. What we're going to talk about in this lesson is if we take a sample of, say, 40 men, it doesn't have to be 40, it can be 30, 32, any number, it doesn't really matter. Well, it does matter, but we'll get into that later. But what is the probability that an average of some men, so when I say this average of 40 men right here, I'm talking about this sample mean. This whole green circle here is my 40 men. And then I'm going to take the average of those 40 men, which is going to give me this X bar. And then what I'm looking for is what is the probability that the average, the sample mean of those 40 men, and I'm just using the same symbol that's used right there, would be less than or equal to 85. So one, and I'm taking some time to talk about this because I want us to make sure we understand what's the difference between what we have already done and what we will be doing in this lesson.